Hello. Today we will be discussing the topic of letters and expressions. Our learning goal for this topic is to introduce letters to represent numbers and to make sure students understand that letters stand for numbers and are added, subtracted, divided, and multiplied like numbers. Introduction. In algebra, letters are used to represent numbers when the number is unknown. We want to state relationships which hold for all numbers. We want to work through a calculational procedure without specifying the numbers. And we want to show a relationship between quantities without specifying their values. Symbols in early grades are used to represent unknown numbers, and we use question marks, squares, or blank spaces. For example, we have 3 plus blank equals 5. Transition from arithmetic to algebra is usually made in grades 5 through 7. Expressions. A numerical expression is a combination of numbers, parentheses, and operation signs which represent a single number. Here's an example of a numerical expression. An algebraic expression is the same as a numerical expression, except it includes letters which represent numbers. Here's an example of an algebraic expression. Evaluating expressions is when we assign values to letters yielding different numbers. The expression then becomes a number. Here's a comic. Here's a teacher's solution. The word problem: Jane has 14 times as many candy canes as chocolate bars. If she has 75 sweets altogether, how many chocolate bars does she have? On the left, we define the units. So we have the number of chocolate bars is x, and the number of candy canes is 14 times x, because it's 14 times as many candy canes as chocolate bars. And we have the total sweets is 75. On the right, we have the problem. X plus 14x equals 75. We then add 14x plus x is 15x equals 75. We then divide 75 by 15 and get 5. There are 5 chocolate bars. A quick tip for teachers. In word problems, each letter should represent a number and its meaning should be clearly announced. Here's an example of a set model. Containers holding a fixed number of objects work well with these kinds of problems. Here we have 3 color pencil boxes, or 3x. We then have 4 individual colored pencils. If we add 3x plus 4, we will get the total number of colored pencils. Here's an example of a measurement model. Bars x units long can be drawn with or without units. Here's an example of a rectangular array or area model. The number of rows and columns can be labeled by letters, say x and y. The number of squares in the rectangular array is then the product xy. Tips for teachers. Area tiles can be a great tool when teaching children how to use this method. In conclusion, at first, defining letters may be challenging for teachers and confusing for students. Teachers should downplay definitions and make clear that letters, no matter what you call them, stand for numbers. Building an understanding of letters and expressions is important in preparing students to learn variables and functions in the future.